All right, guys, are there any questions over any of the assignments so far? Any question over any of the homework assignments? All right. If there's no question over any of the homework, we're going to go on and look at the lesson for today. And the first thing we're looking at, and this is really starting our section over solving, is this here. Is the property of equality for exponential equations. If b is a positive real number other than 1, then b to the x is equal to b to the y if and only if x is equal to y. So if the bases are the same, then the exponents have to be also. So if we have one base on either side, and they are the same, then the exponents have to be the same as well. Guys, thank you. So for this first one here, 5 to the 3 minus 2x is equal to 5 to the negative x. Because the bases on either side are both 5, and there's only one of them, it means that the exponents have to be equal. Guys, put it away before I take it.
You can have it.
Any questions on what we've done so far? Now we just need to solve for the value of x. So the first thing we can do is add 2x to both sides. Negative 2x plus 2x is 0, giving us 3 is equal to x. I did. I didn't hear any. And this is it. Guys, this is it. Because if the bases are the same, guys, if the bases are the same, then the exponents must be also. So we set the exponents equal to each other and solve for the value of x. Yeah, we can plug it back in to check to make sure it works. So 5 to the 3 minus 2 times 3. See if this is the same as 5 to the negative 3. Now we can plug this into a calculator. 5 to the 2, 3 minus 2 times 3. 3 minus 2 times 3 gives us 1 over 125. So this side is 1 over 125. Now 5 to the negative 3 is 1 over 125. Since they are the exact same, guys, it means that this is the solution. Questions on any of this here? Now we're going to look at the next one. 6 to the negative 2a is equal to 6 to the 2 minus 3a. Since the bases are the same, guys, the exponents must be also. So at this point here, we need to solve. Now the first thing we can do here is add 3a to both sides. Negative 2a plus 3a is going to be a. And tells us a is equal to 2. And that's it. We could plug a back in as 2, and we will see that both sides are the same. Any questions on this here? Any questions over anything we've done so far? Guys? Let's look at the next two. So the next one we have is 3 to the 2a is equal to 3 to the negative a. Since the bases are the same, the exponents have to be also. So that's telling us here that 2a is going to equal negative a. And at this point here, we can solve for the value of a by adding a to both sides, telling us that 3a is equal to 0. At this point here, we'll divide both sides by 3, telling us A is 0. Yeah. Guys, any questions over any of this here so far? So let's look at the next one. Questions? 2 to the 2x plus 2 is equal to 2 to the 3x. So again, because the bases are the same, the exponents have to be also. So we're saying that 2x plus 2 is equal to 3x. At this point here, we can get a by or x by itself, so we would subtract 2x from both sides, telling us x is equal to 2. Any questions over any of this here? Guys. Let's look at the next one here. We have 6 to the 3m times 6 to the negative m is equal to 6 to the negative 2m. Now this one's a little bit different because on the left-hand side we do have 6 twice, but whenever we multiply like bases, we add the exponents. So we can simplify, guys, we can simplify this to 6 to the 3m plus negative m. Guys, if I have to get onto you one more time, it's going to be detention. After that, I'm going to just send you to the office. Guys. Here, whenever we multiply like bases, we add the exponents. Now, we can rewrite 6 to the 3m times 6 to the negative m as 6 to the 3m plus negative m. Now, we can combine these two here. 3m minus m is going to be 2m. So if we have like bases being multiplied, we can combine them and add their exponents. Now, from here, since now we have two bases, one on either side, and they are the same, it means the exponents have to be the same as well. So we'll have 2m is equal to negative 2m. Now at this point here, we can add 2m to both sides, telling us that 4m is equal to 0. At this point, we can divide both sides by 4, telling us m is equal to 0. And that's it. Now we could plug it back in to make sure, but m is equal to 0 is the correct answer. Any questions on any of this here? Now if we look at the next one, we do have 4 to the negative 2x times 4 to the x. Since we have like bases being multiplied, we can add the exponents. So we'll add the negative 2x and x together. On the other side, we have 64. But for us to be able to do this, we need to write it as 4 to an exponent. Now, 4 to what power would give us 64? 4 to the 6 is too big. 4 to the 4th is 4 to the 3rd is 64. So we can rewrite this as 4 to the negative 2x plus x is equal to 4 to the 3rd. Now we can simplify this exponent because negative 2x plus x is just going to be negative x. So what that's telling us is that 4 to the negative x is equal to 4 to the third. And because the bases are the same, we can set the exponents equal to each other. So negative x is equal to 3. To solve this here, we divide both sides by negative 1, telling us x is negative 3. Questions on any of this here? I'm not. Nice. Questions on any of this here? Are you ready for the next one? So let's look at these next two here. Now, again, we need the bases to be the same for us to be able to solve these. Now, the first one I'm going to look at is 1 over 10, 1/10. Now, we can move the 10 from the denominator to the numerator, but to do that, we have to change the exponent from positive to negative. So instead of having 10 to the first in the denominator, the bottom of the fraction, we can move it to the numerator and make it 10 to the negative first. Now the other side, 100, can be rewritten as 10 squared. So what this tells us is that we have 10 to the 2x is equal to, here we can multiply through, negative 1 times x is going to be negative x, negative 1 times 3 is going to be plus 3. So we're able to rewrite 100 to the x is equal to 1 over 10 to the x minus 3, as 10 to the 2x is equal to 10 to the negative x plus 3. Now, since the bases are the same, it means the exponents, 2x, has to equal negative x plus 3. Now, at this point here, we can solve for the value of x. And the first thing we can do is add x to both sides, telling us 3x is equal to 3. And last but not least, we can divide both sides by 3, telling us x is equal to 1. Any questions on this here? Any questions over anything we've done so far? Are we ready for the next one? Now, for the next one, we're going to do a similar process as we did for the one before it. So we need to rewrite 81 and 1/9 as 9 to a power. Yes, sir. Yes, but we rewrite 81 as 9 squared, and 1/9 will be 9 to the negative first. Now we will have to multiply, because our powers of powers multiply, so we'd have 9 to the 2x is equal to 9. We distribute the negative 1, giving us negative x minus 3. And since the bases are the same, the exponents will be also. Now at this point here, we're going to add x to both sides, telling us that 3x is equal to negative 3. Exactly, we're going to divide both sides by 3, telling us x is equal to negative 1. Questions on any of this here? Questions on anything we've done so far? Are we ready for the next one? Now 3 to the 1 minus 2x is as simplified as it gets. Now the main question is rewriting 243 as 3 to a power. Because if we can rewrite it as 3 to a power, we will get the exponents to be the same. So we need to see 3 to what power is 243. So 3 to the 4th is 3 to the 5th is
243.
so we can rewrite 243 as 3 to the 5th. Now doing so gives us the bases that are the same, 3 and 3, which means that 1 minus 2x is equal to 5. And we can solve from here. Now the first thing we can do is subtracting 1 from both sides. Telling us negative 2x is equal to 4. And last but not least, we would divide both sides by 2, telling x is negative 2. Any questions on anything we've done so far? Any questions over any of this here? The other part of the lesson that we're going over today is the property of equality of logarithmic equations. If the logs are the same, one log on either side, and they are the same, then what's inside the logarithms is going to be the same as well. So if we look at this here, we have the natural log of 4x minus 7 is equal to the natural log of x plus 5. Because the natural logs are the same, what's inside them must be the same as well. Which is telling us that 4x minus 7 is equal to x plus 5. Now at this point here, we just need to solve for the value of x. Now the first thing we can do is subtract x from both sides, telling us that 3x minus 7 is equal to 5. At this point here, we can add 7 to both sides, telling us 3x is equal to 5. We can check it if we want to see if this is true. Now, at this point, we can plug everything inside the parentheses into the calculator. We can say 4 times 4 minus 7, which gives us 9. So on the left-hand side, we have the natural log of 9. And if we plug it into the right-hand side, ln of 4 plus 5 is equal to the natural log of 9. Now both sides do give us the same value. And what's inside the parentheses is positive. It's not 0 or negative. Because again, what's inside the logarithms cannot be 0 or negative. Even if it gives us the same value on both sides, it cannot be negative or 0. So here, x equals 4 is the solution. Any questions on any of this here? Let's look at the next one. The natural log of 7x minus 4 is equal to 2x plus 11. So again, at this point, we're going to set what's inside the logarithms equal to each other. 7x minus 4 is equal to 2x plus 11. Now we can add 4 to both sides, telling us that 7x is equal to 2x plus 15. So the next thing we can do is subtract 2x from both sides, telling us 5x is equal to 15. Well, here we can divide both sides by 5, telling us x is equal to 3. Any questions on any of this here? We ready for the next one? So let's look at these last two here, and then we'll move on. Now, looking at this next one here, because both of them are natural logs, we can set what's inside equal. So we'd have 5x plus 2 is equal to x plus 10. Now we can solve for the value of x by subtracting x from both sides, telling us 4x plus 12, or not 12, plus 2 is equal to 10. 4x is equal to 8. X is equal to 2. Any questions on any of this here? Will the next one be any different? Because they're both the same. It doesn't matter what they are. It could be log base 7 on both sides, because as long as the logs are the same on both sides, we can set what's inside of them to be the same. Because for this one here, 5x is going to equal 2x plus 9. Now at this point here, we can subtract 2x from both sides. 9. Then we would by 3, telling us x is 3. Any questions over any of this here? And that is it.